Hi everybody, it's me, Chris, after a haircut. Today I want to show you something easy, I hope. We're gonna do everything from the beginning to the end. My plan is I'm going to show you how to unlock WD drive again, how to get access to the sectors, and I'm gonna show you exactly what the issue is with the drive and how to read it in data extractor. So let's go. This is our patient. This is WD10TMVV drive. So first what we need to do here, we have to change the PCB for the SATA. This is which one? This is 1675. So we should take 1672. 1672. 1672. 1672. 1672. Okay. So T5 screwdriver, actually T6 gonna be better. And here we have two EPROMs. We have two, actually this is SPI chips. So this one and this one, we have to take this one and put on our SATA board. Move it to our SATA board. What the fuck I'm doing? Okay, this is our SATA board. So like you can see, we have a dot on the chip. You have dot here, and we have dot here and here, so it means this is a first pin, so our chip gonna be like that. Okay. Let's clean it a little bit and cool it down. Let's screw it in. I'm keep looking on the other screen because on my second PC I'm running I hope similar case, but I hit some slow areas there, like 7% left from head number 0, from the head 0. So since we have SATA PCB here, we can take our PC3000 portable and plug it in. Let's see what it does. And because I don't remember in which state the drive is right now, I did estimate on it a few days ago. So let's see. The drive spins. Get ready. It got ready. Got an ID. Okay, okay, okay. Do you see how slow it is? This is the issue with this drive. Also here. So first, what we need to do, we have to back up our service area. We can do this on two ways. The first way, the most popular way, is here. So from here, actually, I did that probably. Let me quickly check the profile folder. Yeah, I have the backup here. I have the modules from head 0, from head 1. Okay, perfect. So what we should do, we should make a backup here. Those parameters are like you want. You can read by ID. If you have some problems, you can use composite reading. So the composite reading, it works like if the drive gonna read the module and gonna hit some bad area in the module, for example in the copy 1, then the drive gonna go to copy 0 and check if there is a bad sector. If there is a bad sector, the drive gonna give you an error. If it not, then the drive gonna continue reading from the copy 0. And if it's gonna hit the error there, it's gonna go to the copy 1. That's why it calls composite, because the whole module gonna be restored from 2 copies. Right now, I don't need to use it. I don't need to do that because I already did the modules there, did the backup. Also, if you have issues with the modules, you can use this option here, ignore reading errors. Then the drive gonna read the module with the errors, but after you're gonna be able to fix those modules in the utility. Okay, so this part is done. We do have modules. Oh, there is another way to read modules. You can go You can go here, work with service area, reading modules, and here you have all the modules. From here you can pick up deselect all, and from here you can select only important modules. So what does it mean? Select S, select AD, and select B modules. Let's go into our dir. This is our modules. And here you have the how important modules are. So AD, this is the most critical modules for the drives. You can read those modules. You can save them from this menu here. Yeah. So simply Control U, Alt plus SDB, and you can read the modules. Like you can see, not all of them are selected, and this is another way. Of course, here you can use the different method of reading. You can read only from one copy, you can read from two copies, you can ignore, you can read with ignore reading errors option. There is a lot of ways to get the modules in the good condition. Okay, so since we have those modules here, we saw how slow drive is. So probably our module 32 gonna have a lot of bad areas, yeah? Yeah, did you see? And not the bad areas. Module 32, it's a G list. So it's a list where the drive, when you're using the drive and the drive gonna hit the bad areas, bad area gonna put the address of it in that list and move the data into the spare area, into the spare sector. So since this is a lot, it's not that bad, but still it causes, still it causes the drive is slow because probably there are some relocations in the background. So the whole idea here is wipe the list, stop the relocation, get the access to the customer data with good speed, and done. So we can do this on two ways. We can do this in the RAM, here, slow responding problem option. It's a one-button solution. Also here, it's a permanent, but it's not the fix. So the drive, actually, you can't use the drive after it because the drive gonna be failing. But if you're gonna turn off the drive and you're gonna want to come back into the data recovery procedure, after this step here in service area, you're not gonna need to redo it in the RAM. Also, I noticed sometimes in the RAM, it doesn't work that good like it works with service area. So let's see, let's take a look how big this, how many data do we have here in module 32 right now, and simply go and click it. Yeah, so we're gonna do the whole thing here. So we're gonna disable collection on reload list, clear reload list, disable relocation, and disable smart update. We can do this on both copies like that. We can write it by ID, by ABA. We're gonna use that thing here, that feature here. Right now we need to switch power off and on to update the changes. Like you can see, the drive get ready a little bit quicker. Let's see how the utility works right now. It's much quicker. Yeah, so like you can see, the drive is fixed. Let's see if we have access to the customer's data. Yes, we do, but the data are encrypted. The keys are in the service area, and we can find them. How to do that? Maybe from the beginning. So here, menu, decrypt data, auto detect, and we have the key. Boom. And we have first sector ready. Right now we should check the rest of the data because of course we have only one sector. Let's check the end. We have everything. We have access to the last sector, so it means our translator works fine. To be sure, we can go into the middle and yeah, like you can see on the bottom, LBA changes. The drive reads fine right now, so we can make a task in the data extractor. Data extractor, this is another part of ASLab PC3000 software. This is the part where you can work with the file systems. Okay. And where we can do it, let me check where I have space. This is 1 terabyte drive, so probably I'm gonna do that on one of my NASes. I can do this on Synology, okay. I like my Synology. This is old Synology from the old store. So in this case, we should click no because our data is encrypted, but from that what I know, it doesn't matter, but who knows? Okay, so no. Here, first we should build heads map. During that, the software gonna know which sector is tied to which head. So if we're gonna hit a lot of bad areas, we're gonna be able to turn off the heads, the faulty head, and read the data from rest of the heads. When the heads map is ready, we can go and check what is on the drive. Of course, you can't see it, and of course, we don't see anything on the drive. So, who knows what's going on? Me, I forget about something, of course. So, like I showed you here, our data is encrypted. But because it's late for me today, and it was actually pretty tough day, I forget about something. I forget about an encryption. So what you can do, you can start reading the drive without the encryption and decrypt the drive later, or you can, since we didn't read a lot of data, I think we read, let's see, 17 sectors. We can go here, we can clear the map. Since the map is cleared, we can go back here and we can decrypt the data. What? Yeah, I didn't clear it. Let's clear it again. No, the software read it again. Never mind. Yeah. So the data is cleared in those sectors, but only on the image, on the Synology, not on the customer drives, of course. Let's refresh it, and right now we can read it. So we have GPT partition here. Like you can see, we have HFS. And what we need to do right now, we can go and check if we have access to, if we have file tree. So since we have that, I'm gonna do a few things. First, I'm gonna take a map of catalog file. Why I'm doing that? So since I'm read that without the errors, it means the file tree which I read before is fine. So it means I'm not gonna have errors there. If I'm gonna hit some errors right now, it means the file tree which I read there is bad. The simple thing. A small clarification. If there are bad sectors in the catalog file, the directory tree will be incomplete, and it may be missing some files or entire folders. How to check if we have any bad sectors there? Yeah, we don't have any bad sectors there. Since the file tree is correct, let's do quick, where is that map? Use the sectors map from the bitmap. And we're going to read all the sectors from that map. The drive reads like 15 megabytes per second right now. It's gonna take 9-10 hours from that what I see, if we're not gonna hit any bad areas like that. So in the situation like that, I'm gonna simply stop it and change the settings. So first what I'm gonna do, I'm gonna go less for 500 and 150 here. Also I'm gonna check this one. This is the special reading when the drive gonna hit the bad area here, gonna jump the in this case 256 sectors, and if the drive not gonna have the bad area there, gonna start reading from the back to the beginning to this sector here. I don't need it right now. I'm gonna go back to those sections later. So since I see there is some issues here, probably, yeah, no, this is fine. I'm gonna also change this settings here for 512 and change the block size for 32. let's see how the drive's gonna read right now. And also I'm gonna start reading from the back, but I'm gonna read the chains from the back. So I'm gonna read from the beginning to the end of the chains, but I'm gonna read the chains from the end. Okay, let's go. So here we're gonna match all the chains, and we're gonna read them. Like you can see, the drive reads a little bit slower right now, but we don't have bad areas, and we read only the sectors with the data. In the log we can see, because of course I don't remember which head was faulty, so here we can see which head. Okay, we hit some bad areas on the head number 3. So we're gonna simply turn it off here, and we're gonna come back to head number 3 later. So like you can see, we had problems only with the head number 3. Let's see, let's run it for couple of minutes, and let's see if we're gonna hit any bad areas. I'm gonna leave it like that. I'm gonna get everything from those heads, go back of course to skipped areas after, and we're gonna see how much data I got after 16 hours from now. It's gonna be a little bit faster since we turn off the head number 3. Unfortunately, the drive was unable to read from head number 3. Our customer urgently needed this data and approved further work on the drive, including replacing the heads. So let's get to work. forget about the connector. To check those heads because I couldn't check them in the drive because the drive was without the ROM chip, but from the history which I checked, the heads should be fine. So we just need to screw the PCB here. Okay, and let's listen to it. Where is port 0? Okay, like you can see, the drive got ready. Yeah, we got the ID. Okay, nice. So we can go to data extractor. Find our case. Here we have to change the port because we worked on the different one. Let's see. Nice, huh? Okay, so file tree. Now we have to build a map of used sectors. We can do it here. Okay, so it's like almost 600 gigs. But we can make a submap for only head number 3. Yeah, this one. Only for head number 3. And we have missing 91 gigs. Let's run it. Yeah, it's much better than it was before. Change some settings. And let's see if we're gonna get the full speed here. It's not that fast, but still it's pretty good. Yeah, much better than it was before. So we need to wait something about 4 hours and we're gonna get the customer's data. Nice. I need more coffee, for sure. So like you can see the speed drops down sometimes, but it's still not bad. Before I was getting like, from that what I remember, 10 or 12 bits per second. It was terrible. Of course, I'm gonna go back to those skipped sectors. But first I want to get the rest of the data. This is the end actually of this video. I got everything what was on the drive. I got all the used sectors. Right now there is only one thing to do. I have to go to my bench put the customer heads back into the customer drive, move my heads into my donor drive because I'm gonna be able to reuse them into other case. And yeah, the most important part is to have a really good music. When you're doing a swap like that. So let's go. Of course, I left PCB there. So that's it for today. This is end of the story about WD and one bad head. I hope you learned something. There is a way, of course, to read the data from the other heads. If one of the heads, if it's bad, you can read the data from rest of the heads. If it's good enough, then done. The data recovery is done. If it's not, you have to swap the heads and read just that missing part. I think this is pretty good feature. So, like always, I hope you learned something. Have a great day, and don't delay. Send me your hard drive today. Take care.